So now that we covered all these highly successful architectures that we know perform really well in the ImageNet competition, how can we sort of use these models to help us with our own imaging tasks? And sort of before PyTorch, it wasn't enough just to know the model architecture, because once you sort of code that part up, we need to actually do the training and train the models. Now with PyTorch, the whole scenario where you want to be able to use these models for your own tasks, that just becomes sort of a very simple plug-and-play interface. What I mean by that is you not only get the architecture, but you get the saved weights that were used by the groups that developed these successful models, which means you get to have that high performance ready to go right away. So first, I'll talk about some of the very popular data sets that you may want to explore. So first, again, this is all coming from the Torch Vision library. So again, we're going to use this little data loader. You see here, we're going to use the CFAR10 library, which has 10 classes. There are a variety of different image sets as well. So we'll go ahead and load these. And I just want to quickly show you, what these classes look like. So you can see here, once you visualize them, you have different classes like dogs, planes, horses, there's cats, a bunch of other things. But there's just another image set you can use to train your own models. But a lot of the architectures that we talked about earlier use these types of larger data sets to train their models. So we're going to go ahead now and take a look at those models. So first, let's take a look at just a few of the models that we can choose from. And again, these are all fully trained and ready to go. And I'll talk about how we can sort of manipulate it and just use parts of these models as well in just a little bit. But you can see, all the popular ones are here. AlexNet, DenseNet, we even have VGG, VGG16 with batch normalization. So these are very recent, and they're constantly kept up to date by the PyTorch contributors. Let's go ahead and see how we can use something like the ResNet 18 here. So all you're going to do is just specify a few things. You're going to say where your data is, what's the model you want to be using, maybe specify a few parameters, and then now you're ready to start using your model. So literally you just say model and then choose it from the dictionary of models that we just went through, identify your criterion, tell me what your optimizer is, and then now you can start using the model. We're not actually going to train anything here. We're just going to take a look at what it looks like. And you can see if you print the model, you get the entire architecture of the model. You get to see all the layers, what's happening in each layer. It even shows you, even the batch, down to the batch normalization steps. So you get the full architecture here, and you get the full weights as well. Now we could show you, how you can go ahead and use this, but there's a fantastic tutorial on the PyTorch main page, and we put the link down below. And this is for transfer learning. Basically, what they're going to be teaching you is, let's say you have an image data set of your own, but maybe you don't have a lot of images. What you can do is use any one of these highly successful architectures. And as Alf demonstrated earlier, the earlier parts of your convolutional networks, they will be collecting features that are sort of universal across all different image classes, which definitely will apply to your image classes as well. So you can use the power of these trained networks to train it on your data set, so then only the downstream layers get trained, and only those weights will change. So now you can get terrific performance with just a little bit of data, but using these powerful models. So that's pretty much it for how simple. You can really see how simple it is with PyTorch to be able to use a lot of these models and different data sets. Now, in the next section, what we really wanted to do was focus on making a very clear point about convolutional networks. And what we wanted to do from the beginning was show you that this is not just for image recognition, but it's really can be used as a basic building block for a lot of different tasks. So that's what we want to spend a lot of our time on in terms of code. So we're going to go ahead now and start talking about convolutional neural networks for text classification purposes.